LICO's ChromaTOF Tile can streamline data analysis to quickly find and explore differences between GC-GC samples. Here we're highlighting a project that used ChromaTOF Tile to compare 6 different cannabis samples. We didn't have a lot of information about the chemical details of each sample at the start of the analysis. We expected differences in the cannabinoids. Some of the samples were likely to be THC dominant and others CBD dominant. We also anticipated that there could be different terpene profiles and that there would be other chemical differences as well. We didn't know which samples would have which of these chemical characteristics, though. So we analyzed all of these samples in triplicate with the Pegasus BT4D so that this could be explored. ChromaTOF Tile streamlined this task by rapidly comparing the raw data to highlight the sample differences. For this project, we use the coefficient of variation option in ChromaTOF Tile. This finds differences by calculating the standard deviation across the sample set relative to the mean across the sample set. It's an unsupervised comparison, so it'll highlight any variation within the data. It tends to work well for experiments where any type of difference or trend is potentially of interest. It's also done without assigning samples to classes, so it's a good option if sample groups are unknown or if there aren't clear sample classes in the experiment. The results of processing are compiled in the chemical feature table, which provides a focused list of analytes that differ through the dataset. In the table across the bottom, we have the information about the analytes: name, similarity score, retention index, and other identification details. We also have the intensity information for all of the samples in the columns at the back of the table. These can be set to show the values or a heat map, which can make it easier to visualize the trends. The observed spectral information and the library match are in the top left corner, and the relative trends across the sample set are shown as a bar chart in the top right section. Here we see that limonene is higher in samples 2, 4, and 6. We can also look at other analytes from the table and see that there are a variety of trends. For example, alpha-pinene is higher in samples 2 and 3, beta-pinene is higher in sample 2, alpha-terpenene is higher in sample 5, and linalool is higher in sample 3. We can continue to review individual analytes and explore the differences. We can also perform additional comparisons with the compiled data, like principal component analysis. This can help reveal some of the overall trends between the samples and highlight which are more similar and which are more different. We can see some distinction here in the scores plot. Samples 1, 2, 4, and 6 are separated from samples 3 and 5 on PC1. We can look at the associated loadings, and here we see that samples 3 and 5 have more THC, while samples 1, 2, 4, and 6 have more CBD. Other variability and trends in the data are also captured, and we can continue to explore these from the PCA results or the feature table. Tile helped us focus on the regions of the chromatogram with differences, so that we could efficiently get to this type of information about the samples. It does this by connecting and comparing the data with a chromatographic tiling approach, where grids of retention windows are used for the comparison calculation. We create a data processing method with the ChromaTOF Tile software. Then we select the samples to compare and add them to our method. The comparison option is then selected from the drop-down menus in the method settings. The other data processing parameters here are used to set the tile size and various other thresholds. The library search parameters and retention index landmarks can also be entered before clicking Begin to start the data processing. After processing, all of the retention windows that meet the thresholds are shown here in the hit location window. In the top corner, we see the chromatographic locations where there are differences. In the bottom corner, we see the masses that differ for each of those chromatographic windows, and on the right side, we see the contour plots for each of our samples. We can interact with the data from here and also curate the features for the chemical feature table. ChromaTOF Tile is an efficient way to focus data analysis to quickly uncover more information about the samples. In this example, we were comparing cannabis, but the software can be used for many types of samples when the experimental goal is to explore the chemical differences. A variety of comparison modes help support a range of experimental designs and analysis objectives.